Welcome back to another programming speedrun challenge. Looks like we got some binary stuff today, so let's get right into it. I'm going to move this here so we can have it with our code eventually. Let's see what we got. Okay, looks similar. Copy our path. No global variables, that's fine. Ooh, it looks like we're doing some kind of byte parsing. This is going to be fun. Pick 2. What does that even mean? Format. So I guess it's kind of like a weird PNG where you can have like different formats inside. Packed. Oh, this is a little awkward. They're set. So I guess if all the other bytes, we don't care about their state, so we have to do bitmask stuff. Yep. Color table. Oh shoot, do we have to export as like a... Oh, I guess we just print the data. Okay, that's not too bad. So yeah, it looks like we parse the color table, whatever that is. Otherwise, the data is this. But what even is a color table? Function calls, yeah, that's fine. I guess this is what we expect to see. So we can test for this, I think. But yeah, it looks like he gives us one of these files here. Let's see. Image.pic. What even is this? Image.pic. Is this the same as the binary in here? Ends in CC2? No. Okay, there's probably this color table or something. But I expect, it looks like there's just data at the end, so I'd expect this to be visible in here somewhere. Header AB99. Also, it looks like he only gives us one file to test with, but then we have this basically case thing, right? Where if it's either packed or not, and so we really only can test. We only have a file to test one case. That's kind of annoying. I wonder if he tests against the other case, even though we don't have to have the file to see if it's implemented correctly. Okay, I guess we'll just have to follow the spec basically. Neat rows and columns, okay. Huh. I do wonder if we want to search for like CC 7. No, this doesn't look like it's here. Okay, maybe this is a different test file because he doesn't want us to just like copy paste the result. That's fine. Okay, I guess we'll just have to have confidence in the spec, but we can do that. Let's make this a little smaller. We want to open up initials TN. I think we have our make file already, right? So this will give us IntelliSense with C. Yep, nice. I wonder if he wants us to take in the path. We should probably do that anyway. I always forget how to do this. I've literally done this the last 2 times. I forget the naming convention. We'll do pointers because that's cooler. Because this syntax is basically just a weird pointer. Kind of unnecessary. Let's see. Okay, so I think the first thing is we just should have a function to read this into memory. Actually, no. So he wants, I think he said the main should be clean. fread, fclose, okay. Yeah, so let's just have a function like, ooh, and we can use some nice types here. So C has int.h. We're also going to need like memory. I think memory, does this include malloc? Okay, it looks like it includes string, and then this probably is, this has malloc. Okay, cool. Memory, and then we'll need stdio to do for fread and stuff. So we can do like uint 8t. So this is basically a pointer to an 8-bit unsigned integer. So it's basically a byte, which is what we want here because we're kind of reading. We're prescribing like a value to these raw bytes. And this function is just going to be kind of reading the data in to a single buffer. Read file. Yeah, so basically we've taken the path, and my formatting's still messed up. If I do tab in Vim, it's this, but then the LSP actually wants it to be 2 spaces. That's annoying. I'll have to fix that. I should fix that before the next one. So yeah, well, let's just open up this file. I almost want to copy paste from the last stuff. There's so much in common of just like normal similar. So we're going to read binary. So we want that read equals null. Then we know we couldn't find it. %s for reading. Oh, not caps lock, please. /n, exit with 1, so we show that it failed. I think exit is in stdlib. Yep, okay, cool. So now that we have this, actually let's just assignment 2, this. We're just going to copy the same code from last time for getting the length of the file, because I don't want to rewrite that code. Yeah. Actually, let's we can just allocate the buffer here as well and return buff already. Reading input file, so we get the size, we do that. Then we want to do fread. I guess we can just do a single fread and assume it works because this file is small. And if we give it the whole, if the size of the buffer and the size of the file are the same, it really should just do the whole thing all in one go. It's going to be size. We're going to read kind of one size element. We're just going to read the entire file at once. We'll keep this as elements read, right? Because I guess if this reads, this is actually a good question. I'm not sure about this. So it returns the number of elements, right? And so we're passing in size. We almost want to do like 1 size. So the size of an element is 1. And then so this will be bytes read. And if it doesn't equal size, then either the file like basically changed in size between when we looked at the length and when we actually got it, or there's some buffering thing and it can't read it all in one go, but we're just going to assume that never happens. And we'll just put a comment saying like assume will fill a buffer in one go if the size of the file are the same, right? Okay. Nice. Actually, let's put this here and clang. What's this file? It's not going to compile. That's fine. What's it crying about? Okay, we need to pass path. If we can't read it, we fail here. If we can't allocate memory, we fail. If we can't read the whole thing, we fail. Otherwise, we have the entire thing in a buff. Yeah, and so we're just going to return this. We're going to do a pointer cast here because this is void originally from malloc that we get. Yep. Okay, so now we can read this. So we're going to say, and then this path will be, I think it's image.pick, right? And we're going to have to make a declaration so that C knows what's going on. So yeah, now we got the bytes. Now we're just going to do like parse image bytes. This is going to be similar, except it'll return void and take in that buffer we just read. And we're not going to modify it, so we should make it const. Whoops. Parse image. Yep. Okay, now we're just going to implement this. Okay, and then this is actually when we're going to have to look at the bytes and read them. We also want, this is awkward, because we should have an out parameter that's like size t, except it's going to be a pointer. And this is going to be, we have to modify this. So we're going to say reads path into a, so that they know they have to free it. newly malloc contiguous I'm bad at spelling. Dude, where's my word? Oh, we can just do continuous. That's close enough, whatever. So it puts it in a newly allocated contiguous buffer and writes the length to out, right? So that way we know how long the buffer is. And then this has to be bytes. Okay. Okay, we pass in length, and then this guy needs length as well. I have to reread it. Okay. Image.pic. Actually, we should say it's null, and then if so it's greater than 1. The first one is always going to be the path to our binary that's running. If it's greater than 1, then it means that they passed in an argument. So we're going to say path equals argv at 1. Else, we'll assign it to the kind of the default name here, so that it's assigned either way. And they can override it if they need. Okay, so then let's print out the path we're doing here, reading input image at path with a new line. Did I miss any other new lines? Nope. Okay, cool. Yeah, so parse image. Okay, now we have to start implementing his little spec here. So I'm going to make this guy really small. Yeah, I made my terminals bigger. Hopefully that'll help you guys with reading some of the code. I know it was small last time. Okay, so, and we need to validate this length. So, okay, this should be like bool. Let's include, I think it makes it, oh, and we have to change the return type here. Okay, that's what our function does, so let's implement it. So if the length is less than 4, this is like a binary, so we can just print out what's wrong here. So we can say early return, so that's handled. So the first 4 bytes are the header. So I wonder the Indianness of this. That's interesting. Oh, maybe that's why these bytes were mixed up compared to what I saw in the test file. I wonder if I cat. Let me actually cp downloads image.pic to here. This is hopefully doesn't mess up my terminal. Okay. Yeah, so this looks like an actual valid header here. That kind of makes sense. It's nice Fish doesn't, they don't have weird control bytes that like totally wreck your terminal if you print out a binary by accident. Okay, so if that's there, the header is missing. We could do fread here. I don't like that. Let's just have some helper functions that are like, actually let's make this a pointer, because we're gonna, actually no, we'll have this here. Let's do size t offset equals 0, and basically we'll use this to manage where we are in the file. So we're going to have a function that's like read 32. We don't really want to be a bool though. Okay, this is fine actually. And it's going to take in basically all of this stuff. So the buffer, the length, the offset as a pointer. So basically this function is going to increment offset so that we keep reading future bytes, and it'll also make sure that we don't go outside of this buffer because we know its length. And we'll just do like bool pointer success. Actually no, we'll just return success, and then we'll write uint32t pointer out, and that's going to be basically the value we read. So if uint32t is greater than, so basically if reading these bytes, right? So imagine we have a file of size 4, so it's just the header. We want to read 4 bytes the first time. Offset is 0, plus this is going to be 4 bytes. So it's going to say, okay, is 4 greater than 4, which is false. But if we want to read 5 bytes, now offset, or no, what am I doing? Yeah. Hold on. I'm dumb. This is hard. Offset 0. Yeah, so this function wouldn't happen. Yeah, so imagine now length is 3, right? So we don't have enough data to read this. Offset 0. This is 4. Length is 3. And so this is actually going to succeed because 4 is greater than 3. So now we want to basically fail here. And we'll have like field name. And so basically we can say exactly what's wrong with the file. Truncated. Right, so imagine we try to read the header, there's not enough bytes. We're going to return false because we couldn't read anything. And we're going to say, okay, this the header is truncated, and so we can pass in this string header and then know exactly what's wrong with the file as we're testing. So that's going to be nice. So now we know we're within bounds of the array. It's safe to read that. So we can just say, we can write to out equals, okay, we're going to, this is where an endianness gets interesting. So we're going to do things that we don't know the endianness of the platform. We can assume little because basically all the world is little, but I don't want to have annoying assumptions. Okay, this is fine actually because we have bytes. The compiler should optimize this well. So basically this is going to be 24. So we're kind of reading the first byte. This is an array, offset, why are you crying? Not an integer, what do you mean? This is a pointer, bruh, what? Okay, I'm just going to write this code and then we'll deal with the compiler later. So then we're going to read the next byte at offset, except this time we're going to shift 16, and then the second byte and shift 8, and then the third byte, and then that's going to be our lowest amount, so we're not going to shift up by anything. Dude, what are you talking about? Huh? I'm writing to out. Okay, we're going to need Clang to fix this. I have no idea what's going on. Oop, I just overrided that. We can't do dynamic offset for a pointer? Are you kidding me? What? T. Sorry, I'm not talking. I'm very annoyed about this. I'm stupid. We have to, okay, we don't actually need this. We just have to do this, and then we increment offset here. Why are you crying? Here, goodbye. Bytes. This, I think we can, that's going to increment just the pointer. We want to increment the value behind it. This is fine. What are you talking about? Let's just cast it. And we have to do this. Oh, because this is a pointer. We have to dereference that. Actually, do we need to do this? I think this just returns a size t, or it's literal, so it's fine. Okay. So truncated. We read the first byte. That becomes our highest byte for... Oh, now, okay, now this is assuming it's little Indian. We're just going to make this BE. Yeah, so basically big Indian, we read the first byte in this field becomes our highest thing, right? We shift it all the way up. First one is in the middle, this is in the middle, and then the last one is the lowest. We're probably going to need read 32 BE, or LE, for little Indian. And then this is the one where we can literally just dereference the whole last thing. So we're going to assign to out. This actually gets simpler. We can do some fancy pointer stuff. So basically we're going to dereference the result of this cast. And so we're going to cast this to a const uint32t pointer. The memory address bytes plus dereferenced offset. And then, yeah, and then all this goes away because we just dereference it. And we're assuming it's a little Indian, so it's fine. So we write to out, we increment offset. This looks good. Okay, so now we can read our header. uint32t equals 0. He said it's 4 bytes. Yep. Okay, this actually... Oh, it should be the value pick2 in the header. The next 4 bytes. So this is going to be header 1, let's say. So we're going to say read 32 big Indian. It's going to be bytes length offset. So we can increment it. Out is going to be header 1. Okay, I'm going to call this header magic. And we can test this by trying to read an empty file and sort of say if not, right, do some little error handling. This has to be here. So if this function turns false, which it does when it fails, right, if we don't have enough stuff, that's good. And then at the bottom, we'll just do return true because we still have to read more stuff. But for now, we can do and run a.out. Header bytes missing. Interesting. String. How's length 0? What? Do we not write that? Oh, we don't. That's very important. Okay, length 57. Looks like we're reading valid stuff. That's good. If I run this now, I should be able to say empty. I should read this instead. Reading empty.bin. And you can see if I get rid of this debug, this is exactly what we expect. Header bytes missing. Actually, we can skip this length check now. We don't need this because this function does it itself. And if we run this, header magic truncated. So yeah, we know specifically what's wrong on like the file format level, which can be super helpful for debugging stuff. So yeah, now we need to do this for header 2. That represents the format. We're actually gonna, let's call this magic format. Okay, and so now if doesn't equal, this is gonna be awkward to make these bytes. Because we're just gonna run into Indianness. What's a good way? Because we can't basically just make an array of bytes and dereference it. We should actually just look at the hex dump image.pick, right? Because now we know that these first bytes are the correct thing from when we catted it out. It doesn't equals. So it should be this. That's some string. How do you do hex print in C, I wonder? I think it's just %x, right? Hopefully that works for 32-bit. Expected, got magic. And we need a new line so it doesn't look gross. /n, boom, boom, boom. So now if I do vim empty, it's not going to be empty anymore, but I'm just going to make this definitely not the right thing. So now if we run it on empty, yeah, invalid magic detected. But if we take this away, so to use the default thing, still invalid. Okay, what's wrong with this? So we got 5-0. Is this, what is going on? So yeah, we expect 4-9, 5-0, 3-2, 4-3, but we get, this looks very corrupted to me. Are we calling the wrong function? BE, yep, BE's right. What's going on here? We can make this smaller still. Truncated, and we're reading stuff here. Assigning to out, shifting. Okay, maybe we need to cast this to unit 32 before we do the shift. Yeah, but we might just be reading garbage here. If we don't do this, that could be wrong. Or maybe there's something else. Oh, this is all the same line, whoops. Okay, cast this, please. Okay, that's much nicer. Let's try this. Yeah, what the hell is this value? Bro, what? This looks correct to me. So I'm not sure what exactly is going on here. We write to out. Man, I'm really missing Rust debug macro right here. We're gonna do kind of a cheese thing here. Except we're just gonna look at the raw bytes of what we read at these different offsets. And we don't need any of these parentheses or this. This actually goes here. And we're going to say %x, 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 %x. All right, so hopefully this will help us debug a little bit. Okay, this is not right at all. Do we read in a buff? This is not even close to being right. Offset should be 0. Yep, it is 0. That's fine. Let me read this. Are we comparing this too early? Okay, we should fail here. Whoops. Okay, we do fail there. That's good. This looks correct to me. This is expected business. And this is the value pick 2. Yeah, that's the ASCII for it. That's fine. So what is going on? Is this not doing the right thing? Buff. That's the dest. Okay, I'm just gonna log out, do the same debug thing in here with the first bytes of the actual file, right from fread. So it's super raw, except there's no more offset. Yeah, sorry this is going so slow. It's hard to speedrun when you write in a bunch of bugs in your code. Offset, bytes, and this is buff, 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 buff. What are you crying about? Oh, we need to cast this bad boy. Except this is now B, 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 B. Okay, it's getting the same thing. We're reading image.pick. We open the path that we print. Something is very wacky here. This is not right. I hope this resets us to the beginning. Seek set. Seek from beginning. Yeah, that should be fine. fread 1 size. What? What? This is insane. We're just not reading the right thing at all. Oh. Oh no. Ah, hex dump. Come on. Come on. Dude, look at this. Okay, so hex dump, it prints 16-bit chunks, but it prints them as little endian. So actually, if I do hex dump, how do I do this? Image.pick and then pipe this to hex dump dash. It should read from standard in. How can I cat just the first byte? And oh, that's the number of output lines. That's not going to work. I could use DD. It's fine. Okay, I know exactly what's wrong. So this, we're actually, our expected magic is not expected. It should be this. Does that make sense? And so this is actually, wow, hex dump actually sucks. Like, why would you ever want to look at 16-bit chunks? There has to be a mode to disable this crap. Yeah, we want 1 byte. 1 byte hex. Where's 1 byte hex? I don't want octal. I don't want octal. I want hex. What is this? Dash C, is this the same? Okay, now this is right. Yeah, okay. Yes, this is actually what we want. So you can see if I cat the file, the readable bytes are the same, right? This is pick2 AB99, and this is the same stuff he wants. Ah, okay, that's very annoying. Yeah, so actually these are the bytes we expect for the first four, 50, 49, 43, 32. I know it's not decimal, whatever. Deal with it. This goes back, okay. Now this should actually pass when we run it. Yeah, okay. Let's delete some of this debugging crap. We don't need this, we don't need this, or this. File size, we want that. Okay, this is gone. This should all now work. So we read that, and now it's going to be the same thing. If this needs to be bigger now. Let me make this a little smaller, just so we can see the code pretty well. Yeah, wrap set, okay. Let me just get the raw PDF. This is getting very annoying. Yes, okay, there we go. Yeah, so now this should be AB99. So this is the next 4. 1, 2, 3, 4. This can be AB99. And this actually makes sense because I know 6-1, this is A. B is the next one, so it's +1, and then these are the numbers, where 3 is the first one, and then this is 9 is actually showing that it's a 9 here. So we're going to say, it's basically going to be the same thing, right? So 0x, and we're just going to concatenate these together. And so if format doesn't equal expected format, we'll copy the error handling because I don't want to retype this. I got to get slightly better with Vim here. There's some better shortcuts I could use. Invalid format, got expected. Okay, got 0. Do we, this is still magic. This should work now. Okay, yep, so we're getting to the bottom here, the return true. We also do want to print out here where we actually read it. So if this fails, exit, this isn't Python. And then else return 0, we don't even need exit. Right. And we'll just put parsed image successfully. Yep, parsed image successfully. So we're getting to the bottom of the function, return true. Now we can look into this stupid color table. So we got that. A chunk of data, the first byte's packed. So we're going to have a similar function for this. It's going to be like the simplest form of this. It's going to be read 8, length, offset out, this is going to be 8. 8 is greater than length, truncated, the field is truncated, and this is literally going to be, we don't even have to cast this. We're just going to go bytes at, right, because it's already a byte. We increment this by 8. This is guaranteed to be 1, right, in standard, so we could just hard code the constant. This is a little more clear because it's checking this and all these types align now, so that's fine. So we can say uint8, what is this going to be? Chunk of data, packed. So now we're going to do if, it's kind of the same thing as we're doing before, read 8, length, address of offset, address of out is going to be packet, packed field missing, yep. Yep, this will print for us if it's wrong, so we can just return. So now we got our packet, or packed, not packet, sorry. Packed, right, now we can run this. Packed is 97. Is there an easy way to print as hex, or as binary? Okay, so it bits 2 and 7. I wonder if he calls this bit 0 or bit 1. That's confusing. So I'm going to call this, assume this is bit 1. So this is bit 2. This is set. This is, must be, I'm not sure. I guess we'll have to, yeah, actually let's assume this is bit 0 because it's shifted 0 to actually access it. And then if that doesn't hold because we can't parse this file when it should parse, then we know that it's his off by 1 error. Otherwise we're fine. So so we can do some nice expression stuff here. So if it's 2 and 7 are set, otherwise, yeah, okay. Following the color table, there's no color table, okay. Yeah, so I think this is all the branching we're gonna need here. So if, so packet, or packed, shifted right, 7, and 1 equals 1, right? So this is like if this bit is set, we need this precedence to be right. And whoop, bit 2 is set. Now we need semicolon, right? So if it has a color table, I wonder, this one should be true based on what I'm seeing in the hex here. Yep, okay, that's true, nice. If we have the color table, yep, we do the bitwise. If the color table exists, there's another 24 bytes of data. Okay. Okay, so now we're going to say like data size. It can be uninitialized because we're going to set it here. So if it has a color table, there's 24 bytes of data, right? According to the spec. Else, it's not a color table, I guess. There's just 48 of data follow the pack byte directly. So now we can just kind of read in the rest of this here. We will have another function that's like read buff. Actually, no, we don't need to do any copying. We already have it here. We can just validate it ourselves. So we're basically going to do the same check as above. So if offset plus data size is going to be greater than the length, then we know something's wrong. So it's offset plus the size greater than length. Yep, we're doing the same check effectively here. Offset, oh no, we make the pointer to it. Okay, that's even easier. And now we don't need the field name. We're just going to say image data, right? Because that's actually what's going to be truncated. Return false because we failed. Okay, now. Okay, so now if I wonder if I run hex dump with the stupid right flag set, if we'll be able to recognize some of these bytes. 6005. So 1, 2, 3, 4. That's the first one. 1, 2, 3, 4. This is our packed thing. And so 67. Where is he starting? His file must be different. I have no idea what's going on. Okay, we're just going to ignore this printout here. I think this is just the format he wants. Oh, except the header. That's odd. That's fine. So if we're able to parse both of these, the format and this, we should just print all those bytes together. We're going to printf without a new line. Here we're going to print, I think is it %C for character? Bytes sub I for the header. And a new line after. Let's see if this works. Header, yep, that's the same thing. Packed byte. Same capitalization, yep. %D. Packed, new line. Packed byte. I think this is probably hex. That's not the format he wants, but it looks like he wants to specify that. Yep. Okay. Yeah, I really don't like, because this looks like decimal when it actually isn't, so I like prefixing that. We'll stick with that. Hopefully it doesn't break Luke's parser. Now we have our data. And it looks like every 4 we go through it. So 0 eyes. So we're going to say actually, we don't read from offset. We don't even need this. So I0, I is less than data size. Right, so we're going to go through each byte in this data block, and that value is going to be bytes sub I plus offset. Right, because remember, offset, we don't actually increment it. We just do this check. And so now the last thing we did to offset to modify it was when we called this read to read the packed. And so at that point, basically, we have these at 8 bytes. This is our packed byte. Offset's going to be incremented 4 times from the first read, 4 times from the next read, right, by this line here, right, because we're reading 4 bytes at a time. Then we read the single packed byte here, right, which is going to increment it by 1. Size of U and 8 is 1. So then offset's going to be pointing at this byte, which is our first data byte. And so the way we basically access this is that I is going to start at 0, offset is pointing here, and so we're going to read this byte and we're going to go all the way to the end, because this data size is based on what we read here, which should be the end of the file if nothing's truncated or there's extra random bytes at the end. It looks like this is offset, is that a pointer? No, it's not. Okay, why are you crying then? Subscripted value, bytes. It's buff? What did I call it? No, it's bytes. What are you talking about? Let's call it size T. I'm doing something dumb here. Oh, you can't have a different name. Okay. Yep. So we're loading each byte. That looks correct. Now we're going to printf %x byte, right? And it looks like every 1, 2, 3, 4, 5, 6, 7, 8 times 4 is 32. So every 32 bytes, he does a new line. And then every... What the hell? Every 3 bytes, he does space? What is this? Okay, whatever. Well, we'll just copy that format. I think it's stupid, but who cares? So if I doesn't equal 0, we're going to need that for both cases here because we're doing some modulus stuff, and we don't want to like add a new line at the beginning. So if I mod... what are we going to do here? 3. So 54 is 1, F8 is 2, 1B is 3. We want to add a space on the third one, or before the third one. So if I mod 3 equals 0, printf space, else if it's mod 32, new line. This should work. And he wants uppercase. Let's do that. What? Okay. 1, 2, 3. The first one's 4. That's odd. I mod 3. It doesn't equal 0. So when I equals 3, oh, we need to do this before we print the byte. That's fine. Just to kind of like set up for the next one. Hopefully this won't lead to spaces at the beginning. I'm gonna just edit this image.pic and just add a bunch of crap at the end. Oh, it's not even gonna read this. Yeah. I bet though, if we go to the end and delete this byte, we should get payload truncated. Uh-oh. Are we not reading the whole thing? There's extra bytes we're missing? If I just go to town on this thing, what happens? Offset plus data size. Huh. Okay, maybe his, maybe this isn't a color table. Okay, now it's truncated. Okay, so I'm going to assume that his things are off by 1 and make this 6 and make this 1. And we'll CP this back to reset it. Are we getting more stuff now? What? Printf/n. Are, huh. %d/n. I'm sorry guys, I thought this was going to be a lot better. I made a lot of mistakes here. Data size 48. So it looks like 48. So now it's parsing as no color table, which should, I think, correct. So let me go here, delete a single byte. So if this is correct, now this should be 47 bytes, assuming he gave us no trailing bytes in the input file. This should fail. And it doesn't. Nice. Oh, we also want to print... actually, let's not use printf for this. We want to print the digits explicitly. So the problem here, if you look, there's some zeros in the file, right? Because in his thing, maybe there's some 0 digits that are printed. No. Okay, not in his file. But this gets confusing to someone, right? Because if there's missing zeros, there should be 6 hex digits here. You don't know where this actually goes. Because if we print 0, it'll print a single digit when it should print 2 zeros. So this should be like 060002, which would give it 6 digits. Printf doesn't do that. I don't think there's a way to do that. In Rust, you could specify trailing zeros, but not in C. So we got to do this manually. So we're going to say hi nibble equals byte. So we're going to shift it down. Oops, not bytes, byte. And then we're going to AND it with 1. So we're basically going to extract 4 bits at a time. And this is going to be low. Here we don't need a shift. We just want to grab those bits directly. And what is this formatting doing? Are you kidding me? Oh, it thinks it's a weird cast. Okay, there we go. And now we're going to say, yeah, now this will work. Printf %x in a string. We're going to do the high first and then the low. Right, so now even if it's 0, it should print 2 zeros. Yeah, so you can see that's exactly what I said the first time, 06, 0002, because that's sort of how you can parse this to make sense, except now it's always 6 digits, so it's more obvious. The problem now, though, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 22, 23. Actually, this is 24 bytes. And we only want to print it. So if we're printing the 24th byte, we want to do it on a new line. Actually, this should be fine. It should be correct now. Yeah, these should be uppercase, big nibbles. And we want a printf at the end just to kind of clear out if we do printing later. We don't want to print data size. Data size. Oop. Where's the print for this? Here. We don't want that, and then it looks like he wants us, if it succeeds, we don't want to print anything, we just want to print that data. Is he printing the whole thing? 669? What's this initial stuff? That's what I'm confused about. This doesn't match at all. I'm just going to assume that he's using a different file. That's the only thing that really makes sense. And I think we might have tested this earlier. If I delete a single byte, this should now fail. Yep. Image data truncated. Okay, cool. Nice. Okay. Yeah, I think we're done. I'm just gonna do some more testing here, make sure this all looks good. Yeah, hopefully this is a better time. This one, I think normally they kind of build in difficulty. I think this one is a little faster than the second one I've done, and it's less code as well, so just physically less time to write. So yeah, if you stuck around to the end, thank you for staying with me. I'm enjoying this series, a lot going through. We have a lot more labs to come. I heard rumors of in class that we're going to actually make our own shell in C. I did this 2 years ago in Rust, actually. My roommate was taking the class at the time. Normally you take this class sophomore year. I'm taking it senior year due to like scheduling issues. And so actually, for fun, I did the assignment even though I wasn't in the class, but I implemented it in Rust. And so that's another video on my channel. But now we're going to do it in C for real. So it's kind of a pre-read because I read his, he gave me the PDF at the beginning and I did it in Rust. But yeah, it'll be a fun time doing it in C, getting like really raw with all the pointers and the memory. Yeah, so it should be a good time. Hopefully you guys will stick around and I'll see you again in the future.